When we talk about technology, we're talking about one thing that is very important, which is computers. So understanding technology, understanding even programming, because it's part of technology, we need to understand a lot of things. We have to understand computers. We have to understand how computers work. We have to understand how technology evolved. We have to understand what is a CPU, but we also have to understand the building blocks of technology. So in the next minutes, we're going to talk about IT, information technology. Now, this is not the IT that you hear about. This is the foundation of technology that I need you to understand how IT works. Understand, for instance, what is a CPU and what is a RAM. Understand how computers work, but also understanding how the internet works. What is a server? What is a client? And how does the communication happen between a server and a client and all of that? This is what you're going to be learning next. Okay, let's get started. Well, we're going to talk about the basics of computers. So we need to understand how computers work. And we're going to look at data storage and file systems. We're going to look at network and connectivity, how all that works. And of course, we're going to have an overview of the internet, how really the internet works. And I know this may seem very mundane, but the truth of the matter is there are some concepts about how the internet works that's important for us to understand before we move forward into understanding about cloud computing and AWS. And we're going to look into understanding servers and clients, the relationship between what a server is and what a client is, and how those two come together, how those two communicate. Okay, so before we understand how computers work, I think it's worth talking about, first of all, defining in essence what a computer is. I like to look at a computer, in this case, as an input processor. So the idea is that a computer is any device that can manipulate data, which means can perform a series of tasks automatically, that's a key word, which leads to computing a result. It is a really simple concept. A computer, if you look at a computer, just this box there, it needs input. So whatever input we're giving to it, and then we expect to receive an output, in this case, a result. So if you're using a computer and you hit the enter key, that is the input, and the output would be something will happen on the screen. So that really is at a higher level what a computer is. Now, a computer, of course, has parts, okay? Two different distinctive parts. We have the hardware, which is the physical parts of the computer, and then we have the non-physical part of the computer. Now, the physical part of the computers, we have CPU. These are just some of them, some of the parts. We have CPU, we have storage, we have RAM, we have input devices, we have monitors, we have keyboard, mouses, or mice in this case. These are the external physical parts of a computer. Internally, we have what we call the non-physical parts. These parts are what we call software components. These are the things that we can't touch. They're like these abstractions that enable the hardware to perform tasks. So a computer, in essence, needs software because that is what enables the hardware to perform tasks. So essentially, software is what allows a computer to actually run and do the tasks. Okay, we'll talk more about CPU, storage, and RAM in a little bit. Now, going deeper, understanding about the software, we need to look at exactly what software is. So software is a collection of programs or instructions that tell the hardware what to do. As I said before, this is the glue between the hardware and, in this case, the internals of your computer. Because the main idea of the computer is that the computer needs to compute. It needs to take an input, do something to it, and then we get an output. Now, software includes a lot of things. Software or programs includes a lot of different things. It could include, for instance, your operating system, which is, in this case, could be for Windows, for Mac, or Linux, right? The software that governs your computer. Okay. It also could be something like an application, such as Word, or Google Chrome, editing software that you use to editing photos or videos, and so forth. So that is the idea of what a computer really is. Now, we talked about a few things here. We said that computers process information because that's the whole thing. And in this processing, we talked about the CPU. Now, CPU is very important for computers because this is the central processing unit. As the name implies, a central processing unit, you would imagine this is the place where every processing that needs to happen in a computer, that's where it goes through. So, well, what is the CPU thing? This is the hardware component that does a lot of things. Mainly, it processes the input. It also is the orchestrator for execution of instructions, and it transforms input into output. So the output in this case is a result, is what I call a more usable output. This means we can input something that perhaps is not very usable, and we expect the computer to compute something to transform that data, whatever it is that is, the instructions that it needs to do and everything, and then we have something that works, something that makes sense to us as humans, and we can use that. In essence, a computer is not just a computer as a computer that you and I know are probably using right now. A computer can be any device that has this capability of processing data and taking an input, process it, and then, of course, spit out an output, a usable output. Okay, so the CPU, the central processing unit, is the key component, hardware component of a computer. Now, there's another part as well, okay, which is the RAM. This is random access memory. Now, random access memory, sometimes called computer memory, it is yet another hardware component that stores information that needs to be accessed quickly. Now, this is very important, as we will see in a little bit how all of this comes together. Now, the idea behind here is that the faster the RAM, in this case, the more RAM a computer has, the faster the CPU will process that information that needs for the computer to actually give us the results that we want, or process the information that needs to be processed and then have the output that we want. All right, so now we talked about CPU and RAM. Now, these two actually work really well together. They have to. So RAM and the CPU do work together. That is the beauty here. Now, it's important to understand this because without one or the other, then a computer really wouldn't work. How does that all work? Let's put it all together. So when you load something on your computer, in this case, anytime you play a game, for instance, from your computer's hard drive or stream a movie from the internet, what happens is that the computer then will load data that the CPU, or processor in this case, needs for those applications into RAM. So in this case here, you can see that the RAM and the processor have to work together. Okay, so the CPU then uses the memory to perform the complex tasks required to deliver your desired experience. And that's how the symbiotic relationship happens between RAM and the processor. So, and you can see that this is very important because the faster the computer is, that means that we have this symbiotic energy, the symbiotic relationship happening really fast. That means the loading of data that needs to be processed in the CPU is going faster, which means then everything works fine, and then in this case you will see that you have a happier experience because everything is loading up really fast, and voila, life is good. Okay, so that is the connection between RAM and CPU. This is the reason why RAM needs to be fast. The speed of your RAM determines how quickly data flows in and out of your CPU. So if your RAM is low or is too slow, then that means you will spend a lot of time looking at the spinning wheel cursor on your computer, which is something that most of us don't want to experience. So really what all of this means is that the more RAM we have, the faster your computer will have, because that means the transfer of all of the data that the CPU needs in order to run your application, it's going to be smooth, fast, and efficient, which again, as I said, that will give the better experience to the user, the person who's using your computer. So computers must also be able to store data. That's very important because all the data that is stored in RAM, that is not stored forever, right? So it is a quick process that happens, just loads that data that needs to pass onto the processor so that your program can run. So once you shut off the computer, then all of that is gone, right? That data is gone. Computers, of course, need to persist data for a very long time. Now let's talk about the data storage and file systems. So this is how information is organized, stored, and accessed on a computer. Data can actually be stored in many different file formats. So you've seen text formats, we see PNG, JPEG, PDF, and so many more. And also this data can be stored on different storage devices. So we have what we call hard drives, we have SSDs, which are solid state drives, and so many other storage devices out there. Computers also have a different way to store data, which is file systems. Now, file systems is a little bit deeper, in that is the way an operating system structures and organizes, as well as keeping track of files and directories inside of the computer. Now, keep in mind that operating system, we're talking about the software that governs the entire computer. Now let's talk about data storage categories. So we have primary storage. So this is, for instance, temporary volatile storage, such as RAM, which is used by the CPU for processing, right? Now, this is fast access speeds and usually more expensive meaning that it takes a lot of energy for this whole process to happen. And data also is lost the moment that we turn off the computer. So if you turn on the computer and you want to run application like a game application or a video editor application, we go through the process that I showed you earlier, where the RAM will get all of the pieces, the data it needs to pass to CPU, so that CPU can then process those tasks real fast and boot up your application that you want to run. The thing about that also is that the moment you turn off the computer, that data is gone because it's just very temporary. And then we have the secondary storage. So this is non-volatile storage, which means it's not temporary. Now, this is good for saving data for the long term. This is the category where we have hard drives and SSDs. Now, these are slower than the primary storage because really they don't need to be fast, okay? But they are larger capacity, which means they also retain data without power. So that's the whole idea. Your hard drive, when you turn off your computer, whatever you save in your hard drive, it stays there. All right, and then we have the tertiary storage, which usually is used for archiving data that it's not frequently accessed. So you've heard, for instance, tapes, that is part of the tertiary storage. Now, of course, these are very slower and cheaper in nature than the secondary stage. And we usually use those for backups because remember, we're not using the information or the data that is stored frequently. So we can just back up and just stay somewhere safe. And then we have the cloud storage, which is very exciting because now data is being stored somewhere else outside of our realm per se, where we can access through servers over the internet. And that's what we're going to talk about more of later. Now, the great thing about them is that these are scalable and they can be accessed from everywhere. That's the beauty. If you, for instance, use Google Drive or Dropbox, you know that you can access that information that you save there from anywhere in the world, which is wonderful. All right, so now here is a file system overview, a visual overview of a typical file system on a computer. So you can see at the top here, we have Jerry. So this is what we call a folder, or in computer terms or IT terms, this would be also a directory. So we have a directory here called Jerry. And the thing to keep in mind is that when you have a directory, you can actually add another directory inside of it, as well as a specific file type. Okay, so here we have a directory. We can have data as another directory, right, inside, in this case, of Jerry. And Jerry would also have novel folder or directory, as well as tools and a document A, document B, and so forth. And the hierarchy can keep going because you see we have data as directory, and inside of this directory here or folder would have file.txt or file.txt and file2.txt. That is the idea. So in this case, also inside of a directory, we can have other directories which would also have other children directories. So that is indeed the hierarchy. So this tree here, as I would like to call it, could be very, very deep or wide. Okay, depending on the situation. Now, the great thing about this file system, the way it looks, the way it's organized, the structure itself makes it easier for the operating system and, of course, users to be able to store, as you see, store data, as well as organizing and retrieve those files and directories easily, because there is indeed a tree-like structure. At a low level, these file system also provides access permissions, because what happens is that the operating system in a computer may say, for instance, well, the data directory cannot just be accessed by anyone. By anyone, I mean a user, the computer user, or maybe other applications in the computer, right? Other softwares. Because that's the idea. All of the things in a computer are communicating with each other, as well as the file system. So some users or other applications may be may not have permission, for instance, to access the data folder. So the operating system itself can provide access permissions for each one of these files, as well as directories and folders. Okay? So that is the structure of a file system in a computer. There's, of course, a lot to it, but in general, that is indeed how it works. That is the structure. All right, so next we are going to look at network and connectivity in computers. Now, the great thing about computers is that they actually can connect and communicate with each other. This is wonderful because that's how the internet actually works. That's how we're able to send messages to somebody who lives far, far away from where we are. That's the beauty. So let's look at network and connectivity in computers so we understand exactly how that works and how that happens and all the things that go with it. How do computers actually communicate with each other? So there are two ways that computers can communicate with each other. So the first way is through cables. So it can plug in wired cables and computer A and computer B, and maybe B and C and D and so forth, and they can communicate with each other that way. And the second way is through wireless. Right? So there's this abstraction of wireless, meaning that now we don't have to communicate through cables. We can communicate through the magic of air, per se. So the idea is that wireless, now we're going to join a Wi-Fi network, which allows us to connect to other computers. Obviously, we want to be able to connect to multiple computers. And when that happens, so we have computer A, B, C, D, and so forth, we want to connect all of them together. This is what we call a network. So we're linking multiple computers together so they can communicate. Now, to be able to create a network, we need something, right? Because we need a device that will link them together, some sort of a hub, a connector per se. And that thing that we would need, it's called a switch. So switches, they're like intersections within a neighborhood. So what they do is they do direct data to the exact house. In this case, a house is a computer. So that way, that data goes to the correct computer. It knows exactly where to go. Now, the beauty of switches is that they are also able to connect to other devices. In this case, you may have a tablet or a cell phone, and those devices now can connect to this network via Wi-Fi. Now, this kind of network is what we call LAN. That stands for Local Area Network. So it's local because all these devices are close in proximity to one another. For instance, your home network or a network at your school, at your office, your business, okay, that is a local area network. Now, it is important to know that in this case, the computer can only connect to each other, which is in this case is the purest form of LAN. So we're not connecting to the internet. The great thing about LAN is that you have a lot of different possibilities here. So first of all, we're connecting all these computers. You can also connect, in this case, of course, they are connecting through the switch, as we discussed. You can connect to your tablets, your phones, or any device. This is through Wi-Fi, but you can also have a printer connecting to your LAN. This is why it's some sort of a self-sustained network, because you can have, for instance, you can imagine you have all these computers are connected through the switch, so they know how to connect to each other, talk to each other, but also other devices can be part of this network, such as tablets and phones. And in this case, you can also connect a printer. So now you can also send print jobs to your printer so you can print out your files, your documents, and so forth. But the great thing also is that you can also have, let's say, a server on the side that you want to connect to the network. Now things are getting a little bit exciting, right? So essentially, this server would serve all the computers, which now are what we call clients. So this server can serve all the computers or all of the devices in this network. In this case, they're called clients. You can serve them files, documents, and also the server can be used as storage. So having our LAN here, we said that all these computers, all devices connected to indeed our network, these are what we call clients. So as storage, the server would, in this case, keep all the files, and the computers in the network would then be able indeed to access those files as well as modify them. So for instance, if this would be a business LAN, then the people would work on document changes, then save those documents to our server. And then if anyone wanted, they could retrieve those documents and work on them and do the same thing and modify them and do all the things that they need. So all of that is going to be all in the same network. Now, there are different kinds of servers. So this is a file server because it deals with files, but we can also have what we call a print server. So a print server in this case would be responsible for print jobs of the clients. So in this case, the computers in our network, right? So now these print jobs would not go directly to the printer. Instead, they would go through our print server and then directed to our printer. Now, one thing to notice also is that at this point, we are still not connected to the internet. In fact, there's also another type of server that connects to the internet. There we go. So the server that connects to the internet, it's what's called internet server. And the same thing happens. So connection to the internet also needs to pass through the server, in this case, internet server. So you're seeing the idea here, right? So we have a very contained network that we can control, and it can be useful for many use cases. Some companies also have web servers. So these servers, what they do is they serve the web. So this is where they can host a website, for instance. Some companies also have mail servers because they want to be able to receive emails through their own servers. And so now you can see that you have literally a very contained system network of computers and switch and clients that are communicating with a server, different kind of servers, and at some point you can also connect to the internet. So now instead of just being this one contained thing, you also are able to connect to the outside world, but you still have your contained network that you can control and do all the things that I've shown you here. The great thing also is that we're not limited to having just one LAN, right? Because we can actually create different LANs. We can create different LANs and combine all of them through a router. So that is a router. So the router is connecting to the switch of each LAN, and that is how these different entities, these different LANs can connect to each other. So we have LAN A and LAN B. In this case now, instead of a LAN, we have what we call a WAN. So essentially we now have a wide, bigger network with a wider range. Now, keep in mind, though, that at this point, we're still not connected to the internet. We're connected, in this case, with all other devices in our LAN and in the same WAN. So with our WAN here to connect to the internet, we need a third device. So in this case, we will need what we call a modem. So a modem transforms the signals from the network Wi-Fi waves to signals that can be, in this case, transmitted or can be sent to the internet, reaching an even wider networks. And so now you have a LAN, a WAN that is connected or can be connected to the other networks in the internet, because now we have a bigger range of networks out there in the internet. So these signals can be sent through telephone lines or TV cables to reach almost any place on Earth. So now we're opening up our small, rather WAN, a little wide network to the internet, which is just a plethora of different networks that we can tap into. So we know that we need switches and routers for the interconnection between LAN A and LAN B, and of course a modem to connect so that we can connect our wide area network now to the internet. What happens nowadays is that internet providers simplify everything. Instead of having those three items, the switch, the modem, and the router. So now internet providers put everything together into one device. So all in one switch, router, modem device. That is indeed what allows us to connect directly to the internet. So now our network to the right here. So I simplified a little bit, but could be LAN, simple LAN, but it also could be a WAN connected to LANs and so forth. Now through this all-in-one switch, router, and modem device, now we can connect directly to the internet that way. I'm hoping you're understanding exactly the overall idea of how a network of computers works. Now we still need to think about, okay, how does this connection really happens, right? Because we understand that we have in a LAN, of course, we have computers and a switch, so they are supposed to connect. The switch connects these computers together so they can communicate with each other. Well, for this communication, as we talk about this, we kind of abstracted that out. For this communication to happen, we need a few things. So the computer needs to have, first of all, a unique address, what we call the IP, and a MAC address. We'll talk more about that. So essentially, you just think of an address as you would have 153 East George Lane or something like that, right? It also needs to be able to speak the same language, because it is indeed as if you were speaking, as if these computers were speaking to each other. So they need to have a common protocol, in this case, the same language, so they understand each other. But they also need to find the right path, the right routing, so they know where to go, where the data needs to go, to which address. And of course, the switch is the director. So the switch directs data to the exact place where to go. So these are the main things that need to happen in order for this communication to happen. First, we need to have an IP address. There needs to be a protocol, a common standardized language, so these computers know how to connect and talk to each other. And we need to find the right path that we talked about, the router. That's what it does. And the switch in this case is director, because it directs the data to the exact place where it needs to go. So at this point, you should have a very good idea, solid idea on how network and connectivity happens in computers. Okay, so very good. And I'll see you next. Okay, so now we're going to look at the internet. So we're going to look at how internet works. First of all, what is internet to start with, and how it works. So what is the internet really? So the internet is a global network of computers and servers and devices that are interconnected, that are connected with each other. They can communicate. Now, it's important to know that in order for them to communicate, they need to have what we call a standardized protocol. So these are rules that are standardized or are agreed upon, so that these computers are able to connect. These networks, computers, servers, and everything are able to communicate. Also, it's important to understand that the internet is not just one thing. The internet is a bunch of networks that are interconnected to communicate with each other. So the internet makes it way easier for us to be able to share things, share information, share data, share resources across the world really, really fast. Now, one question that most of us may ask is that, is the internet a physical thing? Can I go and touch it? Well, the answer is yes. The internet is actually a physical thing, but also it is indeed an abstraction. Let me explain. So if you look at this map here, you can see that there's a lot of things going on. And then we have these red dots as well as these red lines. What these are what I call the physical parts of the internet. This shows us that the internet is indeed a physical thing, and as well as an abstraction, and I will show you how. So as you can see, these are actual cables deep in the ocean floor that connect all over, that are connecting countries through different continents and so forth. So this is something to keep in mind when we talk about the internet. So these cables are part of a larger network that we call the internet. So essentially, the internet is actually a physical thing because it requires ocean floor cables to connect the world. So the whole world is connected through cables. That's essentially what I'm trying to show you here. The thing about the internet also is that it's not just a central thing. There's not just a place where the internet is being controlled, and that's a beautiful thing, as I will show you in a second. So the internet is what we call a distributed network. What does that mean? Well, that means that the internet is a large number of independently operated networks. Okay, so let's look at this thing called distributed network. I think we need to understand a little bit further. So the internet is fully distributed. What that means is that, as you can see here, we have a centralized, decentralized, and distributed network. If you look closely, there are so many differences between these networks. Centralized means we have a center. Everything connects to the middle. Decentralized, as the name implies, that means there's not really a center of anything, right? We have a few centers of each one of the nodes, which has these nodes that are connected to it, but then we have another node that's connected to the main, so it's not centralized. There's not just one unique center. Distributed network here, you can see that it's like a web where each strand connects to many others. So you can see this point here connects to this one, connects to that one, and this connects to that one, and so forth. Now, there's a strategy behind the reason why the internet is a distributed network. The main reason is actually that of its security. This means there's not a central control which is very advantageous because if there's something that happens, let's say at this point here, this node, there's fire, there's something that happens that destroys this node, then it's just most likely going to damage this area here, and the rest of the network will still work. Whereas if we look at the centralized network, if something happens in the middle, then everything is going to be affected. So that is a security reason why the internet is indeed a distributed network, as opposed to having a centralized network. Now continue here. Let's look at the advantages again so we can see a list of advantages of having a distributed network versus a centralized network, as we saw here. Okay. So a distributed network has a lot of advantages. First of all, there's no single point of failure, as I said. So in this case, if one part fails, then the rest of the network can still function, which is wonderful. And there is an improved performance and speed because there are more paths and connections, which means there's less congestion. If you think about it, if you have a packet or you have information that has to go from here to here, well, if this leg here is broken, something is happening, well, it can always go find a way to go this way, that way, that way, that way, that way, and come back to where it needs to go, right? So that's exactly what we mean when we talk about improved performance and speed, because if something happens to the one path, it can always find another path to get to the destination. It may take a little bit longer, but there's that option. And of course, there is the scalability, right? So it's easier to add more connection. We can add another connection here, which is going to connect to here, which is going to connect to there, and so forth. So we can make this as large as humanly possible and continue making it larger. Okay, so it's easier to add more connections because everything doesn't have to be or doesn't have to go through one single point. There are so many points that are interconnected. And of course, decentralization means freedom. So because we don't have a central point of control, the control in this case is spread out all over the place, which is good. If something happens in the middle here, then it's not going to affect anything else around it. So control is spread out, which means no single entity has complete control. So you could say it's like democracy. Now, it is important, again, I have to repeat this, in order for all this to work, we need to go back to this idea of protocols. We said that the internet is a global network of interconnected computer devices and servers and so forth that have to use a standardized protocol, a standardized way of communication, a standardized language. So protocols essentially are rules, standards agreed upon on how these machines can communicate with each other. So it's a common language. And that is very important to understand that in order for anything to communicate, there needs to be a common language, a standard agreed upon to facilitate the communication. In order for all these computers to connect, these servers to connect to each other, they have to talk to each other. We know that. And how do they talk with each other? They have to have a standardized way of communicating, a common language, a protocol. Now, all devices in the internet must have a unique ID. This unique ID is what we call an address, an IP, or a MAC. It's just essentially just a number, an address. So IP stands for Internet Protocol. So essentially, as I said, is an address. Is an address which has to be unique to a device, machine, or server on the internet. Now, this is very important, as we'll see later, because it's just think of your address. Your address has to be unique to you so that whenever the mail person has to deliver something, they know exactly where to get that something to, right? They know the address where to deliver that. If they didn't know the address, it would be very difficult to get the package or the mail, right? So that's what the internet protocol, the IP address, is very, very important. We'll talk about machine communicating with each other in this vast, large network that is the internet. So next, we're going to talk about internet communication, how that really works. Now, let's look at how this communication happens, this internet communication really happens. So at a high level, you have a computer that needs to connect to another computer somewhere on the internet, right? It could be a server, could be another computer, could be a network, doesn't matter. The simple activity of visiting a website is just asking another computer, in this case, for some information. So what happens here is that we are just sending a message to IP address 156.243.656, right? And so once that computer, on the other hand, could be a device, a computer, or a server, receives that message, first it has to acknowledge that it received that message is not corrupt and all that stuff, right? Once that is acknowledged, then it will receive the message, it will read the message, and it will know that this message is coming from IP address 116.235.016, right? So that's how they communicate. And then what will happen if it knows that information, it will then send a response back. Okay, say, okay, there is a response. That's what you were looking for. The client computer in this case will receive the response from the server. That is the communication that is happening here. This is why I've been emphasizing the protocol, the IP, the internet protocol. This is very important because that's how computers actually communicate. Now, obviously, numbers and all of that stuff, IP addresses, that doesn't really make sense to us humans. We actually don't like to use numbers because they're not very useful. In fact, we don't really use IP addresses on a daily basis, right? When you want to search for something, you don't look for an IP address. You just type, for instance, www.mywebsite.com or www.google.com, and then you expect to receive something from the server or from networks or from computers, from a machine that would know what to serve you. So now, because we know that we use letters or we write domains like this, www.mysite.com, but computers don't really know what that means. That means there's got to be some sort of a system that can decipher what that domain means, right, into, in this case, an IP address, so that it can know where to go to fetch that information that we're looking for, right? So there is such thing called DNS. That's when a DNS, in this case, a domain name system, all it does, it's just a server out there. All it does is just the middleman that goes ahead and takes whatever we pass onto it, searching mysite.com, and it knows how to find the corresponding, I should say, IP address. So this is the job of the DNS. Right, for example, here is what would happen. So if you go on a computer, you can say, hey, I'm looking for a www.usa.gov.gov, right? So what happens then is that the server, the DNS in this case, is going to say, okay, I don't know the IP address, but I'm going to look it up. Well, what happens, the internet is so large, is that there are so many other DNS servers out there. We have the .gov server DNS, we have the .net server, the .com, and so forth. So what will happen now is that our server or DNS is going to go say, hey, do any of you know how to get to this address that we typed, right? And then it's going to traverse through all of these different servers, different DNS really, until one is going to say, yep, here it is. It knows the IP address, which is 106.203.611. And that is going to be sent back to our DNS. And then, of course, our DNS is going to say, hey, this is great. I'll save it just in case next time I may want to use that again. And once it's saved, it's going to go ahead, of course, because we asked for that. That's when we are going to able to then receive the correct place we want to be, which is the USA.gov.gov. So that is essentially how the internet really works. The important part to remember here is that there's got to be a communication. There's got to be a protocol communication. There's got to be a protocol with which all of the machines need to abide by, because it's a communication, right? We need to understand the same language, but also there's got to be some sort of address, right? So every time you are typing on your computer or typing on a browser, you are literally asking DNS somewhere to say, hey, go find me that. And then the DNS is going to transform that, finding the corresponding IP address, and make sure to serve you, because you're the client, the correct information or the correct destination where you want to be. So we talked about servers and clients, so you have some ideas of what servers are and what clients are, but let's dive a little bit deeper so we have a better understanding what servers are. So servers are just computers. So they're actually powerful computers that provide resources, provide services, and data to other computers or devices. So that is the idea. So you can see here, we can have these 3 computers, or just an example, and the computers are connected to the server so they can get resources, files, and so forth, or services in the form of software that are working on the server, and they get results. In this case, these computers could be able to save information and retrieve information from the server. That is essentially what a server is. The main thing to understand here is that servers serve clients, which are in this case devices, computers, and the idea behind it is that these devices and computers, they request resources, data, and many other things from the server. So these computers at the bottom here that are being served by a server, they are called clients. Now let's look at the client-server communication. Now it's important to understand here, we have the client to the left and the server to the right. The server is always listening for incoming requests because that's all what a server does. The server is just a powerful computer that is listening to clients so that it can serve. So the client will send a request and the server will acknowledge that it received that request. It will find the information that it needs and then send back a response to, in the case, the client. That is all that's happening. Now we can blow this up in a larger scale for talking about internet. This communication is happening constantly, repeatedly, in such a high speed that we don't even think about it. Okay? But when we break it down, you can see that is exactly what's happening, this client-server communication. Client sends a request, the server is always listening, listens, acknowledges that a request was received, and sends a response back. Now, we talked about protocols, so we need to understand that these response and the request, response back and forth, we need to have a protocol. So there are many different protocols that are used. Now, these protocols will define the format, timing, sequence, and error handling of the messages exchanged between client and server. Okay, so I want you to think about how we communicate with other people. So we need to have first a language both parties understand. I'm talking here and you're listening, hopefully, and you understand what I'm saying because I am speaking English and I'm assuming you do speak English as well. And so you understand English. So we need to have a context so we know what's being talked about. Okay, same thing with computers. And also, we also need to have some sort of sequence in our conversations. That way there's order and logic as the conversation happens. So HTTP stands for, in this case here, that's a protocol, stands for Hypertext Transfer Protocol. This is the basics, this is the most used protocol. So whenever you are getting images or you're sending and receiving text format via the internet or audio or many other multimedia, you are using HTTP, which is Hypertext Transfer Protocol. There is FTP, which stands for File Transfer Protocol. There are many others there, but these are the main ones. But the most used one, of course, on the internet is HTTP. We have to understand that with the internet, the client computers don't actually directly go straight or communicate to the servers. Right? They actually connect through the internet. So this is the global, as you know, the global network of machines that are interconnected. And in this case, the clients will connect to that global network of machines. And then that's only then that it connects to the correct servers, depending, in this case, on the types of requests. So once a response is ready from the servers, the information, data, or resources are sent back to the client using the same route through the internet. In conclusion, the client-server model is a complex and I would say nuanced system of connections and communication. So from the moment a connection is initiated through the very careful orchestration of requests and responses to the eventual closing of the connection, each step is governed by establishing protocols and standards. This is very important to understand. Now, this design, right, the client-server model, enables diverse and dynamic interactions, forming the basis for much of our modern digital communication and interaction. So essentially forming what we call the internet. Now, whether browsing the web or sending an email or streaming video, we all rely on this client-server model to connect and communicate across the digital world. Okay, let's go ahead and look at some server types. So servers are categorized based on their specific roles. So we have web servers we've talked about. So these serve pages. So in instance, you can host your website. So people can say, for instance, www.mypage.com, and then they serve that website. Okay. We have file servers. They store files. And we have database servers, these manage databases. We have many other kinds of servers. We have mail servers and so forth. So far we've learned a lot. So we've learned about a computer. What is a computer? We understand data storage and file system, which governs an operating system in a computer. We learn about network and connectivity, which is very important. We learn about LAN and WAN, right? So local area network and wide area network, differences between those two. And of course, we also learn what is the internet and how it works. So we did a deep dive to really understand all of the pieces that make up the internet. So by now we should have a very good IT foundation, and I know there's still a lot more, of course, and we'll tackle what we need to tackle as we go through the course. But at this point, if you have been following along, hopefully you have been, you should have pretty solid foundation about IT, the very, very good basics foundations. All right. So thank you so much for your time, and I'll see you next. I hope this video was helpful. I hope you are now well situated understanding how computers work, what is the internet, what is a server, what is a client, how computers connect with each other. Because now I know some of you may say, well, I don't want to be in IT. I understand. But if you want to become a good programmer, a well-rounded programmer, then you've got to understand these basics of IT. So that's the reason why I share this with you. If you like this, let me know in the comments, and let me know if you like this kind of content and what else would you like to learn. Thank you so much for your time, and I'll see you next time.